further about the step 3. So in this video I will let you know about the step 3. Now we have converted this whole y thing into w. We have to convert this into a w thing. The basic purpose is, I told you that what is the basic purpose? To make this non-linear equation into a linear equation, right? Okay, now in this this equation, this first term y to the power minus n dy by dx, we have to select this and eliminate this y, and we convert this w and substitute in this equation. So I am substituting this y to the power minus n dy by dx as this term. So this equation becomes 1 over 1 minus n dw by dx plus, here y is w, y to the power 1 minus n is w, so I am replacing it as w, and p of x remains p of x because x is an independent variable here. Only y and w is y is changed into w, and f of x also remains as it is. So now you can say, and I'm in the next step I'm multiplying this 1 minus n, so dw by dx, n is a constant, so 1 minus n is also a constant, so don't be bothered by this term. 1 minus n into w, p of x equals to 1 minus n into f of x. So this equation is a linear equation. Now we can solve this linear equation. So this equation is a linear equation, and now we can solve this linear equation with the help of the basic method of solution of the linear equation, right? So we are doing it. So this is basically the procedure for solving the Bernoulli's equation. Okay, now we are doing the example, specific example, how to solve the Bernoulli's equation. Okay, I am arranging this. It's this one. So example number 1 is solve this equation. First of all, you have to identify again step by step that whether it is separable, it is not separable. I'm looking at this and judging that this is not separable. If it is not separable, then check that whether it is homogeneous. If it is not homogeneous, then you have to check that it is it an exact equation. If it is not exact, then if it is, check that whether it is a first order linear equation. It is a linear equation or not. Let me check that. Dy by dx plus 1 by x is p of x here into y equals to, here left hand side is to some extent is a differential equation, first order, but when we come to the right hand side, due to this y to the power 2 factors, condition number 3 for linearity, g of x, forcing term, it should be a function of independent variable, but here due to the y to the power 2 y square factor, it makes it a non-linear equation. That means it is a Bernoulli's equation of order 2. So this is a Bernoulli's equation of order 2, right? Step number 1, select this y to the power n. Here n is 2, so n is 2. All right. Okay, first step is to remove this y square from the right hand side of the equation. So what you have to do, you have to multiply it with minus 2. So multiply y to the power minus 2 on both sides of the equation A. Of equation A. What it becomes? Y to the power minus 2 dy by dx plus 1 by x y to the power minus 2 into y equals to x y to the power minus 2. So solve it. Plus y to the power minus 2 plus 1 is 1 by x into y to the power minus 1 equals to, here it 2 minus 2 becomes 0, y to the power 0 is 1, so that becomes like this. So this is step number 1. So in the next step, you have to select this y along with the p of x that we are concerned with. So let this be w, y to the power minus 1. So to that respect, dw by dx must be equal to d by dy chain rule, y to the power minus 1 dy by dx. Okay, and then minus 1 y to the power minus 2 power rule dy